Awesome. All right. Well, thanks for having me. I'm excited to get a chance to visit LA. Let me put this back in my pocket. OK, my name is Ben Coe, and I am the lead registry engineer at NPM. So I basically lead the team that doesn't build the CLI where you type in NPM, but I build the part that it's interacting with, so the backend infrastructure. Over the past, I've been working at NPM for about a year and 2 months. Over the past year, we've basically been completely rewriting the infrastructure that NPM runs on top of. And actually, as of 3 weeks ago, we basically swapped out NPM's infrastructure entirely, hopefully with not too many people noticing. So tonight, I'm going to be talking a little bit about why we changed around our infrastructure, where the infrastructure came from. So I'm going to kind of, if we have a bunch of, put up your hand if you use NPM at work, or oh, that's good. So I'm going to basically give you a story about kind of the history of NPM, where it came from, and if I don't cover stuff that you find interesting during the talk, I'm going to stick around for Drinks.js, and I'm excited to talk about this stuff. So without further ado, so what I'm going to be talking about. I want to talk about why we built Registry 2.0. So why did we move away from the original infrastructure that we've been running on for 3 or 4 years? Because there has to be a good reason to do something like this. It's been a big undertaking. As I said, I'm going to tell a story about our architecture, past, present, and where we're planning on going in the future with our architecture. And I'm going to give you a look at Registry 2.0. I'm going to talk to you about what's actually available now as of a week ago that you can actually play with right now on your computer. So what were the goals for Registry 2.0? Well, most importantly, some people don't know this, but NPM is a company. We have 11 employees. We're trying to make money. And one of our first, one of the most obvious monetization strategies for NPM was the ability to have private modules so that you can, within your company, you can bring the open source workflow you have, and without using private Git repos, you can actually install NPM modules with your company's private code on them. So we had to get the registry to the point where you could have private modules. We wanted to better support teams and organizations. So basically, it's right now your workflow on an open source project is you can either install an NPM module, or you can be one of the team administrators, basically, who has complete admin access to the package, can publish it, can unpublish it. We want to have more granularity. We want a company to be able to, say, have contractors who only work on, tend to work on packages, and you put all 5 contractors on a package. So orgs and teams. We wanted a platform that we could do exciting stuff on top of in the future. So NPM, we have a lot of things we want to do as a company. We potentially want to be a deployment platform. We have a lot of neat ideas. We wanted a better foundation to implement some of these ideas. And furthermore, we want to all be racing around Oakland in sports cars, so we want lots and lots of money for all of the NPM employees. So we're calling this Registry 2.0, but if we take a look at the history of NPM, this is really the 3rd major iteration of NPM, which I'm going to go into now. So in the beginning, there was CouchDB. So NPM started essentially just as a CouchDB application. What does that mean? Well, let me read to you the description off Apache's CouchDB project. So Apache CouchDB is a database that uses JSON for documents, JavaScript for MapReduce indexes, and regular HTTP for its API. So basically, if you've ever tried Hadoop, or if you've ever heard of kind of MapReduce, Couch drank the MapReduce Kool-Aid entirely, and it's completely based around the idea of MapReduce searches on data. Doesn't matter that much. It also really drank the RESTful API Kool-Aid. So basically, every operation you do with Couch is a RESTful operation where, if you want to create something, you do a put. If you want to update something, you do a post. In a lot of ways, CouchDB is a lot more than that, though. It's a little bit of everything. It's kind of an application framework and a database at the same time. And I want to talk to you a little bit about how it became the foundation of NPM. So why was CouchDB chosen? So first off, I did not work at NPM or on NPM when we chose CouchDB, so this is just a post hoc kind of what I think might have happened. So if you've ever installed an NPM module, which it looks like a lot of you have, package.json is a very free-form document. You don't have to set all of the fields. We encourage people to create new fields, like if you've ever used Browserify, you can add a browser field to it. We don't have a strict rules about the structure. CouchDB is a JSON document store. It basically allows you to put any JSON structure in for the package.json. So this seemed to make sense for kind of the loose kind of data that was represented by a package. CouchDB has support for attachments. So if we chose this as our database, as well as being this great store for your package JSON information, it could store the binary data that made up your attachments that are the actual source code you install when you do an npm install. It's a very JS-centric technology. The way you query it is with JavaScript. The way you interact with it is with JavaScript. It grew up kind of within the same community that npm grew up within, and it made a lot of sense as a technology for this reason. Like Isaac was good friends with Michael Rogers, who was very closely involved with Couch, so it grew up in the same vacuum. It's highly extensible. You can make it so your own custom JavaScript runs when someone performs an update. So for instance, when someone publishes a new npm module, we were able to say, oh, this looks like completely invalid package JSON, and we could reject the rate to CouchDB. So you can start to build kind of application logic on top of it. Supports authenticated sessions. So we could actually hobble together a website on top of CouchDB, and we could actually have you type npm login and have that all taking place as an interaction with CouchDB. Long story short, if you wanted to, you could basically build an entire application on top of CouchDB, which was exactly what we did. And that's where kind of the history of npm comes from, is we had the CLI client, which Isaac was doing a lot of work on. And we had the CouchDB database that Michael Rogers was doing a lot of work on. And you can still see we still have it open sourced. It's called npm Registry Couch App. It's just you install it into CouchDB, and it gives you the backend infrastructure of npm. Unfortunately, there was trouble at brewing. And I want to talk to you about why. So about a year ago, just before I started working at npm, there was a big problem in the Node community. Basically, npm was going down all of the time. So it was becoming a meme that basically I can't do my work at work today because npm's down again. And it was not good. At this time, we were handling about 6 million installs of packages a day. We were down all the time, like I said, and we didn't really have the resources to fix the problem, which is a big reason, along with getting sports cars for everyone. A big reason for why the npm company exists is that we wanted to have the resources to be able to make an actual stable registry. So step one for the npm company, once we formed a company and had money to throw at the problem, we started hiring people like me. And we started trying to stabilize the npm registry so that it would not be a joke in the Node community. So first off, as I said, we could just store all of the attachment binary information inside CouchDB itself. This did not mean it was a good idea to store all of the binary information inside of CouchDB itself. So where we found ourselves was we basically had 200 gigabytes of packages inside CouchDB, which represented all the modules you might install, all the versions of all those modules, and it was starting to take up a significant amount of space. Couch was not really built for this, so it was starting to be that if you created a new CouchDB server and had to replicate everything over to it, it started to take just an obscene amount of time to create a new CouchDB server from scratch. It would take in the order of days. It takes hours and hours to replicate and frequently failed. So people who were trying to keep replicas of npm, it was failing all of the time. First step towards getting npm stable, we came up with a clever hack. So up until 3 or 4 weeks ago, every time you published a package to npm, it still went into CouchDB as binary data. We then had this little thing called the skim worker that was always running in the background, running around, chasing after all the package publications, pulling them out of CouchDB, putting them on a hard disk somewhere, and then we were serving them from the hard disk through Nginx, but they did still go through the CouchDB, which meant without significantly changing our infrastructure, we could continue using that npm couch app, but we could have the benefit of not having the 200 gigabytes of attachments inside CouchDB, which was huge for us. That wasn't the only thing we had to do to get npm actually running stably, though. Basically, we had one big CouchDB server, and it had way too many things it was trying to do. It was handling reads and writes. It was handling the public replication. So we, for instance, had an npm in Europe that was just constantly replicating from us. So we basically had this one primary server that was serving that. Handled searches. So it turns out one of the most expensive things npm does, if you type in npm search on your command line, don't do that. It actually has to download, it's like 400 megabytes of JSON at this point to do a search of the whole npm registry. So we realize it's ridiculous. It takes like 15 minutes to search. But it's still one of the biggest loads on our infrastructure, and we don't want to just take that feature away from people. So it was yet another one of those silly things we were doing. So it turns out we were asking too much of it. And because we were asking this one system to do way too much, it was becoming very difficult to isolate those specific problems. So we didn't know search was one of our biggest problems because we hadn't isolated stuff into components. So along with getting attachments out of CouchDB, which was huge, we did a few other things to kind of bring us to the stable npm of a few months ago. So let me talk to you about what the state-of-the-art system looks like. As I said, the attachments are out of CouchDB, so we no longer have this 200 gigabyte database. I think that it's a couple hundred megabytes. We still store all of the meta information for your packages in CouchDB. So if you look at the kind of the JSON structure that gets written to disk, that you enter into your package.json, that is all still in CouchDB. So all the meta information is still in there. The packages themselves are served through a CDN. So it turns out that a few packages represent a huge amount of our traffic. So people install Bower or Express thousands of times a day. It turns out a CDN is great for this. So we have all of our packages are backed by a CDN. Another interesting thing that I think is, if anyone here does backend infrastructure work, the SSL itself is a really big CPU hog. So the fact that we were having all of our CouchDB servers terminate SSL, so we had, at this point, 10, 20 CouchDB servers, and they each had the responsibility of serving you your packages, but also terminating your SSL connection. And you end up with a lot of contention on the CPU. So what we ended up doing was separating, like we said on the prior slide, it's great to reduce the number of responsibilities you have. We also made it so we had boxes that were specifically only terminating your SSL connection, and then you could speak plain HTTP to all your CouchDBs. So that's a big performance gain. So let me show you a diagram of the state of the art. So this is about a month ago. And what you basically had when you typed npm install in was you hit the Fastly CDN. If the package was available in the CDN, you'd get it very quickly from somewhere close to you. If it wasn't in the CDN, you'd hit one of our many read replicas for the information. If it was JSON, if it was the binary of a package itself, we had tarball servers serving them over Nginx. We have this little guy here who just chased after package publications, tearing them out of here and putting them into here. So it's kind of weird, but actually worked very well. And then if you happen to do a publication, which is very rare, actually, we have 5,000 installs a second right now, but we only have about one publication a minute, call it. So our publications actually were going directly through to our rate primary. And then public SkimDB, npm in Europe, has its own box to replicate from as well. So this worked great. Jump to February 2015, so a year after npm formed a company, we're now, instead of 6 million downloads a day, we're handling 40 million downloads a day. We've had 100% uptime for a few months in a row at this point. I think I might have broken that record when I rolled out some of the new stuff last week. We're having, as an ops team, we're having significantly less panicking and significantly more sleeping, which is great. So this kind of brings us to, this actually brings us to the story about Registry 2.0, because when npm was founded as a company, there was no cycles to put towards building things because we were just in a mad panic trying to keep the registry up and running. By getting the registry moderately stable, we were in a position to actually start building some cool stuff, which is why we actually now have Registry at 2.0. So first thing we built is we built a new website. So it meant that we could support the web team, and we could get a nice new website built. So I'm sure everyone's seen this. So this was one of the first things we did. The other neat thing we built, which not many people might know about, is you can actually run NPM inside of your company. So if you want to have your own NPM running, we offer it as a service. And basically, you can run a Docker image or an AWS image or whatever. This NPM Enterprise introduced the concept of scoped modules. So as I said, Registry 2.0 introduces the idea of private modules. This concept was initially introduced in NPM Enterprise. And basically, the idea is that, like myself, I can have my own scope. So you can still have Lodash, but you can also have bco/Lodash. And I have the option of making bco/Lodash a private module. So I could use it for publishing all my company stuff there. The great thing about Registry 2.0, or sorry, the great thing about NPM Enterprise was that it basically gave us a few months that we could really start testing and building the stuff that would serve as the foundation for Registry 2.0. Let us test it on real companies, like Walmart's using it, for instance. And so it let us get some revenue coming in the door, and it let us build this infrastructure without testing it on like the public immediately, which was really nice from the point of view of a developer. So NPM Enterprise became the foundation of NPM Registry at 2.0. So basically, if you NPM install right now, you're running almost identical infrastructure to what you could go throw up on AWS, and we would install for you. So let's take a look at what Registry 2.0 actually looks like. CouchDB does some stuff really well. So we have not eliminated CouchDB as a dependency for NPM. CouchDB is awesome at replication. So that little trick we were doing where we chased after package binaries and removed them from the database, that actually uses a replication feed that Couch exposes. We use this all over our infrastructure for creating multiple replicas of NPM so that we don't lose your packages. We use it, it's kind of a cudgel, is that a word? It's a hammer. It's a hammer we use for lots of stuff. So we love Couch's replication. Document store, I think the initial idea that a loose form document was great for package JSON was a good gut decision. Like, we continue to want people to introduce fields. We continue to plan to extend on it. It's nice to not have that in a strict schema. The cool thing about Registry 2.0 is we've introduced a bunch of service-oriented architectural pieces that we did not have before. Furthermore, NPM now uses node.js and NPM modules, which is really cool. This was not something we did. There's a billing service. So we have a little SOA service that handles taking your credit card information. There's an access control system. So the big change between Registry 2.0 and the old NPM is that you can now make it so someone can't see your module. Before that, all modules were public. Now we have to have a rule system where I see a different list of modules than Omar sees, and we need to make sure that we don't show each other stuff. So we need this access control system. We have a registry relational service, which again uses that follow feed concept and creates a relational view of all of the packages in NPM, so that we can run queries on them. And actually, when you hit the website, npmjs.com now, it's even though we have package.json as a loose-formed blob still, you're actually interacting with a relational view of the package.json when you hit the website. The core of Registry 2.0 is NPM Enterprise. I encourage people to play with that. It's fun. You can run it for free on your own laptop if you want to see what NPM looks like behind the scenes. One interesting thing to note is we've been moving away from CouchDB. So all three of the other services are using Postgres. So we're now using Postgres for user accounts, ACLE stuff, billing stuff, and the relational database stuff, all Postgres. So here is an updated diagram of what you now get when you type in npm install. So it's significantly more complicated, but really cool. So basically what happens is we still have Fastly sitting in front of everything. So you still, if you install a public package like Express, there's still a good chance you're getting it through a CDN. It then hits this concept of, if you're typing an npm install, it then hits this thing called front door, which speaks the exact same RESTful API that Couch used to speak. But it then takes the request and routes it to an appropriate part of the system that now ends up ultimately serving the module. And the one thing I'm not going to walk through every component. It's kind of boring. But the interesting thing to note, I think, is that there's a very different path through the system for scoped modules because they have the concept of who's allowed to access that scoped module. So the neat trick we could do was we kept it so public module. We kept it so global modules, Lodash, Express, Gulp, Grunt, they do not have to go through any of the ACL stuff. We're never going to make global modules be private, so we can skip that step. As soon as you use like @mycompany, @bco, @whatever, we then start going through the ACL part, which decides who has access to what. So I'd like to introduce scoped packages to you. They're available right now, which I don't think we've done a great job of announcing yet. Basically, everyone in NPM already has a scope that matches their name. So I have @bco. If you have an NPM account, you have whatever scope matches your name. Within the next few months, organizations are going to also have scopes. So you can have @yourcompany. You can also associate a scope with your own private NPM. So you can run your own NPM inside your firewall. Is that me doing that? OK. You can run your own NPM inside your firewall if you're at a company like Walmart. And you can make it so the public packages come from global NPM. The @Walmart packages come from your internal firewall. And maybe there's one other scope for your open source stuff that is organizational scope on NPM. So the neat thing about these scoped modules, one is by default, they are private. So if you try to publish @bco/foo right now, it's going to default to private access. And you're going to have a paid account to do it. So that's kind of what we're charging money for, is you need to pay money to us to get private modules. Having said that, you can start playing with scoped modules by setting the access to public by default. So you can go ahead and publish, in my case, @bco/foo and access public, and it will work. And global packages aren't going anywhere. So we don't expect that everyone will suddenly move all of their open source projects over to @Bower/whatever. There's always going to be the global scope like Lodash, Express. So here's what a scoped module looks like. Nothing too surprising. I can publish a private module to @bco/r2demo. I can have scope dependencies like my private configuration there. And I can also have public dependencies. So it's up to you if you can have some public stuff, some private stuff. The nice thing is you no longer have the need of, for my private stuff, having a Git URL in there and kind of having to have this Git workflow and this NPM workflow. You end up with a workflow for your private @work stuff that is almost identical to an open source workflow, which I think we do fairly well. You install a scope dependency exactly the same as you install a global dependency. So I was talking to someone about this outside. We haven't released this yet, but within the next few months, I don't want to pin a date on it, we're going to be introducing the concept of orgs and teams, which is going to be very similar to what people are used to with GitHub's orgs and teams. So you're going to be in a position to create multiple teams that you assign to a package, multiple teams within your organization. And then instead of adding one by one every single developer in your company to a module you're working on, you can just add the developers inside your company to a module you're working on. We're also going to have a slick UI for that. So I assume, I'm not the designer, but we have a good designer. We'll hopefully have a slick UI for it. So I want to bring you to tonight. Yesterday, for the first time ever, we hit 60 million downloads in a day. So since a year and a bit ago, we've 10x the number of downloads we're doing a day, which is kind of crazy. And it's not showing signs of letting up. So it's going to be interesting to see how far we can push the infrastructure. NPM finally uses node.js, which I think was kind of an embarrassing secret inside NPM. we had this CouchDB application that like 2 people in the world knew how to interact with, and it's now been deprecated a bit. Everyone has access to private modules now, so if you have a workflow that revolves now around GitHub URLs, give it a shot. See if private modules would work for you. I think it will. If you're in a big company, I think it will get better as orgs go out, but it's already possible to play with them. As I said, I'm available for questions. If you want me to nerd out on anything specifically, I'll be around for Drink.js tonight as well, and around whatever is happening after this, before Drink.js. So thanks for having me.
Is it possible for scoped modules to override the global scope? So for my company, for example, if I want to have people only use up to a certain version of Lodash, can I set it so that they're only allowed to use a certain?
So what you could do, so you could publish Lodash into your company's own scope, but have it pinned at a specific version and then not push updates. So that'd be one way you could get something like that behavior. Other things people have done, like if you run NPM inside of your company as its internal NPM, you can set rules on what packages are actually allowed to be installed through your own private NPM. So.
We used to say hijack aptitude ability so that it will go to our private registry before it would go.
Yeah, we're a lot of companies, right now we have this concept of a whitelist you can use where you can say only these packages can be installed through NPM. And there's only a few big companies using it right now, but that stuff will probably be built out further as more companies use it.
My question was about like binary packages. So for example, like the SQLite library, which can run just native JavaScript, but also has the ability for a binary component. Have you guys looked at sort of packaging infrastructure that allows you to have pre-built binaries for specific platforms? This is
specific. We've had this conversation a few times. Like as a company, I don't know that we have a good idea of how we want to do it yet, but I know some large companies are trying to do this themselves with technology that works with NPM. So I can't speak to anything we're doing immediately, but that is something we want to tackle and figure out, because it would also mean that we can greatly speed up install times and also put those binaries in front of a CDN, which would be really useful. But it's also a very hard problem.
Yeah, because I kind of pointed out to Microsoft Azure, yes, they support Node apps, but you have no binary compiling there. So it's kind of cool. And then natively, you don't pre-put them.
I know of one big company that runs their own NPM, and they basically have a whitelisting rule where as soon as you try to install something that has like a GIP component, then it basically doesn't allow you to install it, and you have to go through like a special process where they pull it into their own binary assets server. It would be neat if we could start to do that ourselves. I totally agree.
The front door app, piece of your infrastructure that you were talking about, is that written with Node, or is that?
Yeah, it's written with. I don't actually know. I should have better numbers. I'm not sure. So yes, front door is basically a translation layer. So we have the ACLE parts and the billing parts and the binary serving parts. And then the main purpose of front door is we have this historical API that the CLI speaks, which we have to make sure to support for years going forward. So front door is basically a translation from the CLI to other parts of the system, written in Node.js.
You talked about like the fast lane for things that don't need ACL service.
Yeah, exactly. Yeah. So basically, it has a simple rule where it's basically, does it have an @ symbol in it? OK, then it has to go through the ACL parts. If not, then we can just serve it right through Nginx right to you, which is nice because it means now if our new infrastructure goes down too, you still have the public registry still pretty much running functionally, so which is really nice.
So after your experience with binaries and CouchDB, do you think that's just not a great road to go down? Is that feature just something on your blacklist?
So I don't think of myself as a CouchDB expert, so I can't speak to what you could do with tuning. But I do know that we've worked closely with people at Iris Couch and really did try to get we used to call it full fat registry and then skim registry, so full fat and skim milk. But the full fat registry we spent months trying to tune and just could never get it working properly, and then pulling attachments out of CouchDB did what we needed to do. But keep in mind, we're very high load compared to a lot of systems. Like, I think we were trying to get it to work before we even had a CDN in front of it. So we were trying to put basically thousands of requests for large binary files to CouchDB a second. So all right.